right, today I'm going to go over chapter, I think it's 11, the exception handling stuff. Again, I've got a different book than you have because I have some of the chapters out of my book. So I don't even have chapter numbers on mine. But it's on exceptions and advanced file I/O. And we're going to talk 99% on exceptions and the other 1% on different files and serialization. We're not going to hardly spend any time on that. You won't have anything like that for an assignment or whatever. All right. I've said this to you before in other classes, and I'm just going to say it again, and that is the fact that an exception in programming terminology is an exception to the rule, so it's not a good thing. All right. As they say there, it's an object that's raised as a result of an error or unexpected event. So it's something that you don't want to have happen. All right. If something unexpected happens and you have not programmed for it, the program just blows up. Now they show you a real simple example of that right here. Unfortunately, the way he's got it laid out, it looks kind of funky. But if you look here, he's got a class called bad array, and there's main. And in main, well, what do we have? We've got an array with 3 numbers in it. So what? They're numbers 0, 1, and 2, correct? So what he should be saying here is for I equals 0, I less than 3. But he purposely introduced an error that says less than or equal to 3. So you get the famous or infamous array index out of bounds exception. All right. I should mention to you also, if you care, I'll mention to you if you don't care, but under the in-class folder for the other day, I did go back and redid both those programs, so they both work. All right, so the test scores 1 and the test scores. These are just text files that have the same information in them, but it's all there if you want it. All right. So you get this right here, the exception's raised, and if you don't account for the exception, the program is just going to stop right there. All right. What happens, just so you know, I'm going to just make it simple. Let's imagine main. All right. Main calls function 1 calls function 2. Everybody get that? So main called function 1 called function 2. Let's say that this code that you see right here, this bad code, was in function 2. All right. If we don't write something to handle it, let's suppose we wrote nothing to handle it. So what happens is you've got an error in function 2. And it looks and it sees, do I handle that error here? And it says, no, I haven't. So it jumps up to the function that called that. And it said, okay, did function 1 have anything that will handle it? No, I don't have anything there either. So it jumps up to main. And it says, does main have anything that would possibly handle it? It says, no, there's nothing there either. Then it kind of jumps up again and looks through object. And it says, is there anything here that could handle it? No. Then it just craps out. All right, so it does go up the call stack, so to speak, looking for something. And the reason I'm telling you that is it would be totally legal if we have main calling function 1, calling function 2. I could put an error handler in function 1, even for something that's in function 2. You don't see it that often, but there may be a reason to do that. All right. So a little bit of history, so to speak, on this. As it says, exception objects are created from classes in the Java API. The API has a hierarchy of exception classes, and some of those are shown. Well, I tried to have you show them here, but for some reason it's not showing that. If you got your, if you have your book with you, it shows you in Figure 1 part of the exception class hierarchy. Not sure why that's not showing here, but it's not. And the bottom line is, just so you know that, there are certain exceptions that you can handle, and there's other ones that you can't. Not everybody hear what I said? It's kind of important because what Java does is it breaks it into, and this is what's in that picture that I can't show you, but on the left, it's got errors, and on the right, it's got exceptions. The difference between these is errors are things that you have no control over. For instance, if for some reason something screwed up and you didn't have enough memory to run the program. All right, doesn't happen often. All right, but you're doing something like that. So errors, you can't sit there and write code that will handle those errors. You know, what are you going to do? You don't have enough memory. You know, there's not a command that you can run that's just going to double your memory. It just doesn't work like that. So the stuff they show over there with errors, all right, the stuff that they show over there with errors, we're just going to disregard basically. We're going to talk about the other stuff that's exceptions. So again, every time that you create your own exception, hint, hint, because you're going to be doing that on the homework, all right, that's going to be extending the exception class. It must. All right, so that's the first thing to just keep in mind there. I guess that was it. It was here. All right. So again, errors we don't care. Well, it's not that we don't care about. We can't do anything about them. We're going to handle the exceptions, and there's different kinds of exceptions, and we're going to hit into some of those too. And you notice when you look here, there's an I/O exception, and notice that under I/O exception is both an EOF exception and a file not found exception. What does that mean? That means that end of file exception is a type of input-output exception. File not found exception is part of a input-output exception. As I mentioned to you the other day, if I'm going to go and put a bunch of try-catch statements in there, if I have a catch statement for I/O exception, and underneath that, I put a catch for an EOF exception, and I put a catch for those, I get an error. Does everybody remember that? You've got to have the more specific errors first, and then the general. But if we circumvent that, and we change the order, it's not going to work. Everybody's cool with that? All right. Question? No, that's the thing was with the runtime exception. It depends on the error, all right? But what I'm saying is Java breaks them up into errors and exceptions, and it says that errors you have no control over, all right? With the runtime exception, I'll give you an example of a runtime exception. It doesn't know it till runtime, so I ask you to input two numbers. I'm going to do a simple calculator, all right? So I type in 1 and I type in 0. And then it says what operation? I say divide. That will blow up. Now, unlike the C stuff that we looked at yesterday, that'll blow up. And it'll give you some kind of a runtime exception. Attempt to divide by 0, runtime exception. All right, so can you fix that? Yeah, just don't allow the user to have a 0 in there. You know what I mean? That'd be about the only way. Now, you could sit there and let them enter a 0, and then what you could do is you could actually search for that. All right, so you could do a try-catch. So when that happens, you can check for that runtime exception, and you could change it to a 1 or whatever, or just not allow it to happen. But if okay, you tell me if I'm answering your question. What you're going to see is the way that you program it is like this. You type in try, and inside of that try statement, I'm just going to put a comment here. You put code that may or may not succeed. All right. And then you've got a catch. Again, there can be more than one of these, but I'm just going to show one. You know, catch some kind of error, whatever it is. All right? And then optionally, what you can put in also is finally. So again, as I mentioned, so we'd have this runs whether try succeeds or fails. And again, as I just mentioned to you, we can have a whole bunch of these. So you come through here and you've got a statement. There can be as many statements in here as you want. All right? And it goes through. If everything is cool, in other words, if there are no errors, it skips all these catches. And we'll come back to the finally in just a second. But if you come through here and you've got some kind of an error, whatever it is, then it looks through here and it says, oh, is that the kind of error you had? No. Is that one? No. Is that one? Yeah. So it never checks the last one. As soon as it finds one that could possibly solve its problem, it does that code and it stops. It can only do one of these catch statements if something fails. It can only do one. That's why, you know, somebody asked this question the other day. If you want to be really picky about it, then the last one that you'd put in here would be something like catch exception E, and you'd put that stuff, and that'll catch just about anything. As I mentioned the other day, that'll even catch warnings. All right. Now this might look a little funny. What do you mean it runs whether it succeeds or fails? All right. And what that is typically what you put in here, just so you know, typically what you put in here is this is used for what's literally referred to as housekeeping. What does that mean? Closing files, closing database connections, stuff like that. You shouldn't be putting a lot of code in there that's gonna do anything else. It's gonna clean up after you're all done. So again, in an ideal world, you've got your code in here. All that code succeeds, everything. So then you jump down here and you do this. But if you've got some code in here and it's working its way through, and all of a sudden there's a problem, it looks and it says, oh, there's my problem. It runs that code, and then it comes down here and does this. Does that make sense to everyone? The finally is optional. You don't ever have to have a finally. Not only that, what most people don't understand is the catch is optional too. It's almost never done that way, but you can have a try with just a finally. I've never seen it like that in code, but you can do it. I can't think of a real good reason for doing it. There might be one. You almost always see it like this. And sometimes if you know, hey, I'm only going to have one error, there's only one thing that could go possibly wrong, and I have no housekeeping to do, then a lot of times you'll just see it just like that. Does that make sense? All right. So that's pretty much what the chapter talks about. Also, so imagine I was in here and I've got, line 1. I'm just going to put 3 lines. Line 2 and line 3. All right. So those are all lines of code. I don't care what they are. It does line 1. Now it does line 2, and there's a problem. That means control literally transfers out to the catch block, and it tries to figure out what the problem is. It's like a go-to. Once it finds it here, one thing you can't do is you can't tell it to go back here. You can't do that. It's just the way that it works. Now, you could put the same kind of code, you could try to fix it, and then have some of the same code that you have up here, put it in down here as part of catching the exception. The problem is, for example, what if the same code that I just told you. Okay, so I come up here. I say enter a first number. Okay, enter a second number. Now enter an operation. Okay, so you come in here, you enter a 1, you enter a 2, you tell it to do divide. Now it attempts to do the divide and it gets hosed up. So it comes down here, oh, math exception. So what I could do down here is I could tell you to enter the operation again. Couldn't I do that? Problem is, what if you enter divide again? You're still hosed, right? So I can throw the same exception again from the exception that I'm in. Does that make sense? All right. And the way that I'll do this is I could, so let's say in here that I just had something, input number 1. All right, input number 2. Input operation. Again, I'm not going to write the Java code, but input the operation. All right, and I'm just going to put here do operation. So again, I come through here and I put in 1, 0, divide, and I attempt to do it. That's where it blows up. Okay, so I come down here. Well, that could be different kinds of, for instance, it might be a number, maybe it's a number format, whatever. Let's just say it's a number format exception. All right. I don't have to call it or anything. If the program blows up, it's going to immediately jump down and look for a catch block. And look for a catch block with something in here that's going to match the kind of exception that I've just thrown. Does all that make sense? Because that's what you're going to see throughout the entire chapter, are examples of that. All right, I'll just leave this up here and we'll come back to it. So again, there's the syntax. Each try and each catch must be in its own set of curlies. Not only that, all right, and this is an important point. I want to make sure you understand this. It's fairly simple, but it's easy to overlook. Let's say that I came up in here and I did this, int number 1, and I'm not even going to give it a value, int number 2, and let's say that you enter a 1 to add, a 2 to subtract, etc. So that's the operation. Okay. Now, I want you to understand, if I have a mistake here with the operation, if I jump down here, I'm going to tell you this, I'm going to ask you why this is true. If I'm in that code in the blue, that code in the blue does not even understand that number 1 and number 2 in operation exist. Why? This is really something unbelievably fundamental. No, you're being way too hard. You probably know. But I'm asking you. Remember, this is a block structured language, right? What do we use to delimit a block in Java? Yeah, and you're defining, so that thing comes to life there and it ends life there. It doesn't know that that exists. So if I want to be able to work with these things down in here, then I have to define them up there. And I've done that. And I've looked at it, what the heck am I doing wrong? And that's such an easy mistake to make. And it's one of those, it's so fundamental that you just look at it and you look right through it. That'll work. Now I can take the number 1, number 2 in operation and use them here, or I can use them here. But the other way I showed you, you can't do that. And again, it's a fundamental, that's a logic error. This, yeah? Yeah, you're right, it does. It relates to scope. All right. So again, here's an example of a try-catch. All right. What that's doing is it's saying, attempt right here, attempt to come in and create a brand new file object that's going to be called myfile.txt. And then here, you're attempting to set up a scanner based on that. Well, why would that ever fail? Well, what if you were doing this someplace where you had no permission to create a file? It probably would never happen today, but what if there wasn't enough room on the system to create a file? All right, or something like that. Or even more often, what are you going to, because I'll tell you this, because this is what we all do. Let's see how the copy works out here today. Oh, real well. All right, I don't even want to show you like that. Let's say that I did this, file equals new file, and then I came down here. All right, and instead of typing file down here, I left the I out. So it said FLE. So it was trying to associate the scanner with something that didn't exist. Does that make sense? It's going to blow up. And it comes down here and it says, oh, file not found. And that's the exception that would run that. Again, it's exceptions to the rule. Right now, everything we've done up till this point, everything, if you did a J option pane or whatever where you ask the user to enter input, you know this. If it said enter your age and you put hello, the program blew up. If it said enter your age and you just hit enter without putting anything in it, the program blew up. Now it's not going to blow up anymore. All right, that's the idea behind this chapter. All right. So they go and they put it into an entire program, but the idea, I think, hopefully at least makes sense to everybody. All right. Now what they're doing here is they're handling it right inside of the method. So this is being handled right inside of main. You can see it. There's the try and there's the catch. All right. It gets a little bit different if you don't handle it directly in main. Remember I showed you before how main call function 1 and call function 2, and I said if there's an error in function 2 but you're handling it in function 1, you have to use a little bit different syntax. So we're going to see that in just a second. And they show you an example, but I mean, again, I think everybody can understand that. This is a good picture here. And again, I don't know what page in the book, looks like 732. The sequence of of events with an exception. So look at that. As it says right there, you attempt to do the file thing. Then you attempt to do the new scanner. If that fails, you jump right down into here and you skip the J option pane statement. All right, as long as you understand that, there's no more to it than that. All right, retrieving the default error message. Notice what it says. Each exception object has a method named getMessage that can be used to retrieve the default error message for the exception. So it's the thing Java would naturally provide for you. All right. Just so you know, and we've talked about this before, but if you look down here, everybody would look on the screen here. You don't have to call that E. There's nothing wrong with calling it E. E for exception. Sometimes if you got a lot of these, like file not found, I'll watch people and they'll put in FFE, file, or FNFE, file not found exception. You don't have to. You can call it E. It doesn't matter. All right. So again, notice we got the E.get message here and there's nothing else. So what does that do? When you run it, notice what prints. Usually a pretty bad message. It's terse, in other words. It just says bad file text. The system cannot find the file specified. That's not bad. All right. But sometimes they are really terse, and they'll put something out there and you'll be like, what the heck does that even mean? So usually you put your own message on there and then you'll append the e.get message onto that. Does that make sense? That's what we looked at the other day. All right. Here's another example. This is perfect because this is the same kind of stuff I was just talking about. So we set up a string with A, B, C, D, E in it, and we're attempting to parse it. Okay, you already saw that the other day. We did something similar to this in C, and in C, when you attempted to do that, it just treated it like 0, but it didn't blow up. Java blows up. All right. So in this case, we've got conversion error. Notice that's our text, the 4-input string. All right. A, B, C, D, E. That's what the system is providing with the e.get message. All that makes sense? All right. It says, recall from chapter 10 that a variable of a superclass can be a subclass of objects. This is polymorphism. And what they're saying here is, it says, a catch that uses a parameter of exception type is capable of catching any exception. So the bottom line is what we said before. If you put that exception in there, that can catch any kind of exception that's thrown. Anything. All those ones that I showed you the other day when we went out to java.sun.com. All right. Multiple exceptions. We already talked about this, but just to say it one more time. Again, notice right here, file not found and input mismatch. All right. If that runs the way it is, then we know that file not found exception is more specific than input mismatch exception. We know it has to be that way because if it's not, if we put it in the opposite order that we should have, we'll get an error message when we attempt to run the program. All right? That's all the stuff that we've already talked about. Now it says here, using exception handlers to recover from errors. So notice, it demonstrates how a try statement can have several catch clauses to handle several different kinds of exceptions. However, the program does not use the exception handlers to recover from the error. Regardless of whether the file is found or not, the program still halts. All right, so it says this example is better. Okay, so let's go through that one. All right, we've got some sales data, we got some really, whatever stuff. So we're trying this stuff. Again, we attempt first to do that line of code right there. If that line succeeds, we attempt to do that line of code right there. If that line succeeds, we attempt to do that line right there. If all those succeed, all we do is we close the file, we calculate. But if for some reason we screwed up here, we hit enter or we hit whatever, and we jump down here, now it's going to go and give us a J option pane, and notice what it says. Skip past the invalid data. So what they're attempting to do is they're saying, well, I'm not going to give you another chance, we're just going to skip it. Sometimes you see stuff like that. Sometimes what a developer will do is they'll say, okay, I know you put garbage in there, so I'm going to replace the garbage you put in there with something that will at least work. Divide, a good example of that would be if you had 0, replace it with a 1. You're going to get the original number you started with, right? But at least it won't blow up. Handle each exception. Again, this should make sense. Please take a look up on the screen here. This is page 715. I mean, hopefully taking a look at that, you're like, well, duh. And that's good, if that's the case. The author is saying you can't have a catch statement in here that has both, that has the number format exception twice, because you already caught it. So notice it's number format exception E here, and it's number format exception E here. Well, I'd never do that. You'd be surprised. That's, again, the wonders of copy and paste. You go and I want to do almost the same thing, so you copy it down, but you just never change the exception that you put right there. And if you do, you're going to get an error message. All right. Figure 1111 is showing you the hierarchy, or I should even say a hierarchy for this stuff. All right. And this, again, in your book, it's what, page 742. So this says, again, if there's an error in here, it's going to keep going up like this. So this is going from more specific to more general. That's all it's saying. Here, illegal, this is what we already talked about this. Illegal argument exception is a child of number format exception. All right? Or was it vice versa? No, I'm sorry, it's vice versa. Illegal format is a parent, so in other words, that's more general than this is. And it says the compiler issues an error message stating that the exception has already been caught. It's unreachable code. And if you say, I don't understand what you mean by unreachable code, again, I believe you do, but just to make sure, let's imagine that I wrote something like this, because you'll see this kind of stuff sometimes in code. All right, I'm gonna say here, x int x equal 3. All right, there's some code here. So there's some code there. Now, so x may or may not have changed, but I'm gonna type in here, switch on x. Case 1, do some stuff. And break. All right. And again, I'm not trying to waste your time. There's a reason I'm actually showing you this, because this is an error that a lot of times people make. I'll make this a default. So if it's a 1, you want to do that stuff. If it's a 2, you want to do that stuff. If it's a 3, you want to do that stuff. All right. And if it's a default, that should never happen. Let's say it should only be a 1 or a 2 or a 3. So if you get in here, that's an error condition. Everybody with me? So if for some reason you got in here and it wasn't a 1 or 2 or a 3, error. All right. So I'll see people write this. I'll just get the hell out. So return. Then they'll put a break under it. And what's the problem with that? What's the problem with that code right here? Well, you're along the right lines. Teresa said you can't have both. You can, but if you've got a return in there, the break can't get hit. You've already returned. That's unreachable code. You'll see stuff that developers do stuff like that purposely, accidentally, or whatever once in a while. When you get into a thing with unreachable code, it's usually something along those lines. Again, the finally, as I mentioned, it's optional. It must appear after the final catch clause. And so it's try in parens, catch in parens, and finally in parens. So what are they doing in here? They're just closing the file. All right. Because they're saying basically it's not worth going on, invalid data, because you gave it a bad file name or whatever. So just close it. If it was open, close it. This is the stack trace. This is what the example that I gave you before, when I said you've got main that calls function 1 that calls function 2. All right. Have you ever noticed before, I don't know if you've ever seen this or not, but you try to run a Java program and you've got errors in it, and it'll show you errors, and it'll show you errors in your files, and then it'll show you errors in some of the Java files. I don't know if you know what I'm talking about or not. That's a stack trace. So it's telling you what method called what method. Here's a hint. If you see those, the error's not in the Java files. The error's in your files. All right, the ones that Java created, it's not in there. All right, I know we don't like to think that. It wasn't my code that was screwed up. It was Java's code itself. No, that isn't the way it is. You did something wrong. There's a stack trace right there. Page 719. So notice, what they're saying here is main called my method. All right, and usually it'll be a lot bigger than this. Sometimes these stack traces are really long. All right, if you're really heavily into a function. And it's good because the one thing that does show you is it shows you the calling sequence. So you can see if your function that's in error is being called correctly, or you know, it's being called by the one it should be called by, and that's being called by the one it should be called by, etc. Now notice they talk about Java 7 here, and the newest Java is Java 8. And one thing about this is if Java 7 handles something, then Java 8 will handle it too. That should make sense to all of you. and so will Java 9 and so will Java 10. They may change it, but what it's saying here is this section of code that's here in your book on page 719, that's guaranteed to work for all versions of Java 7 and above. That's not guaranteed to work for versions less than 7. All right, that's all the author's saying here. And I'm not sure what the author is exactly trying to show you. I went and looked at it, but it's fine. Here's a multi-catch right here. Oh, that's it. You can use the OR. See that? So if you want to do the same, remember the OR symbol? That's a single OR. It's not pipe sign, it's just one pipe sign. All right. What that says is whether it's a file not found exception or it's an input mismatch exception, you want to print the same error either way. So rather than having to put it in there twice, you can do it like this. So, well, that's confusing. Then don't use it. All right. Again, when the exception is not caught, we talked about this already, how it jumps up the call stack looking for it. All right. Until either it finds it or it gets all the way to the top and it gives you an error. Okay. So this is your chance. I mean, as a programmer, this is your chance to handle exception, erroneous types of conditions. And you already know this. If you don't, Java will. And Java goes to the extreme. It says, you're hosed. And it basically just stops the run. All right. And I don't know about you, but if I was asking the user to enter a whole bunch of data, let's say I was asking name, address, city, state, maybe 10 pieces of data. And the 11th piece is your age. And now I accidentally fat finger and I put in my age and I just accidentally hit the letter A. All right. Well, what's going to happen is if I have no exception handling, Java's going to blow up the program right there. I got to run it again and put all that data in again. But if I put it in as a try-catch, I can check that, and if it's a number format exception, I could ask you to do it again. I don't know about you, but to me that's a much better way of handling it than the way that Java handles it itself. Now, they talk in here about checked and unchecked exceptions, another part of the chapter that's actually fairly important here. All right? And it says here, in Java, there's two categories of exceptions, unchecked and checked. Notice, unchecked exceptions are those that inherit from the error class or the runtime exception class. And what they're saying is, those are the ones that you're typically not going to try to handle. All right, you say, well, because Mark asked the question before, he said, we're talking about runtime exceptions when we looked at that picture. The point is, I can handle some runtime exceptions. If you put in 0 and attempt to do a divide, I can stop you from doing that. All right? But I can't stop you from continuing to put in 0. See what I'm saying? Even if you put in 0, I catch it. 0, I catch it. 0, I catch it. You know, unless you do it 3 or 4 times and I put up a message that says, I'm sorry, you're hopeless, and I kick you out, all right? Something like that. But other than that, you can't account for human stupidity, frailty, whatever you want to call it. So what they're saying here is the remaining exceptions, the ones that don't inherit from error or from runtime exceptions, are checked. These are the ones that you should handle in your program. It says if the code in a method can potentially throw a checked exception, you must either handle it or you must have a throws clause in the header. Very important word there. See that word throws? Think about this, because there's 2 words in Java that are both key words. One is throws and one is throw. What's the difference? One has an S and one doesn't. Keep this in mind. I don't care if you write it down or don't write it down. Java throws exceptions with an S. You throw exceptions. So if you want an exception to happen, you must throw it. But Java throws with an S on it exceptions. And you're going to see that from now on. All right. And again, I know it sounds simple. Well, and after we go through this, you go, well, that's simple. But it's amazing, because if you put throw where it expects throws or vice versa, you get an error. All right. Good news is Java's happy to show you that error. All right. So, next thing they talk about here in section 11.2, throwing exceptions. Notice singular. That means those are exceptions you throw. So you can write code that either throws a standard Java exception or one of your own. And they're giving an example right here. It looks kind of stupid, but you can see it. Throw a new exception out of fuel. Again, notice throws and throw. There's the way the author explains it. You like the author's definition better? Hey, go that one. So what are we doing in here? All right. We're saying if this data string is null, we're throwing our own illegal argument exception. Notice there's no E in there. There's no get message. What's going to happen is the program right there will stop, and it'll just come up on the screen, null reference to date component constructor. Since since we're handling it by just throwing an exception, it'll throw that. But if we don't handle it, it'll do the same thing. It'll keep going up the call stack and say, well, you threw that exception, but you didn't tell me what to do. So typically the program will just blow up right there. But again, you throw. All right. We're going to see some more examples of this in just a minute, but the next thing that's in here is creating your own exception classes, which again is on the bottom of page 725. Now notice because this is a good example. They say if you have a bank account, in order for a bank account to be able to perform correctly, there's some things that you want to make sure don't happen. You better not have a negative starting balance. You better not have a negative number passed to a deposit or a withdrawal method. And you better not let the person withdraw more than their balance is. Now again, are there places that let you do that? Well, I can't walk into my bank right now, and if I have $5 grand in the bank, I can't go in there and write a check to cash for $10,000 and give it to them. All right. I mean, I could legally do that. They won't give it to me. But if I'm going out to buy a car, as an example, and I put $10,000 down for a down payment, all right, and I give them a check, there's probably a pretty good chance they're going to contact the bank. On the other hand, if I'm just going to put $100 down, they probably would trust me. You know what I'm saying? All right. It's funny because I know people who've done that. I know people who use their MasterCards. A couple people I used to work with, they each had their own MasterCards. They both had gold ones. They were married, and they both had a $25,000 limit. That's how they put down their down payment on their house. I'd never heard of a person who financed their house before through MasterCard. They each put, they paid it off pretty quickly, but they needed money, so boom, they both had, there was no balance on their I wouldn't do that. Please. Yeah, Jeff told us we should be using it. No, he didn't. All right. So here's the stuff that's in here. So notice what we're writing. We're writing our own exceptions. Everybody hear that? Again, we're on page 726. So we're writing our own exception right here. This is a Java file, public class, negative starting balance, extends exception. As I mentioned before, every time you write your own exception class, it must extend exception. The book I used to use, and I said this to you the other day, said it's also good form that really right there, that should have been called public class negative starting balance exception. Because if it is an exception class, you should put the word exception in there. You can see if Gaddis doesn't agree with that. Either way is fine. Yes. But, well, that's a lot of typing. Yeah, well, life's tough. Plus, you know this, Eclipse has got basically its own IntelliSense built into it anyway. All right, so it'll bring that one up for you. Hell, that IntelliSense would be there if you used Notepad++. But the point is, there's our constructor. All right, so that's calling super. Hopefully now what you understand is that's calling exception. All right, exception has its own thing that Java wrote. All right, what will it do? Not much. But you always call super just in case you have to. So it's going to call super and it's going to say negative starting balance. All right, and right there it's going to stop. All right, unless we tell it to do something else, or depending on where we put it. So there is an example of calling it without passing it anything. So you're just going to get a message that comes up that says negative starting balance. Well, we could also do it where we told you what the balance was. So that's assuming that if this one gets called here on 727, that when you tried to create a bank account, you gave it a negative starting balance. If you put nothing in there whatsoever, that first one would be called. If you put in a negative starting balance, this one would be called. If you put in a positive starting balance, neither one of these would be called. Even 0, neither one of these would be called, the way that it's set up right now. That technically that would probably be an error situation. I don't know if any of you either work in a bank or have, but my guess is if I walked into a bank and said I wanted to open an account, I'd have to have a minimal amount that I put in. No, I just heard giving away free toasters, so I want to open up an account. How much? I don't have any money. I just want the toaster. I don't think they'd allow you to do that. Okay. So once we've got this, we've got negative starting balance.java, then we can come into our code. So notice there's no catch in here right now. But this says if the starting balance is less than 0, throw that. So again, control will go over to that, okay? And we're passing it the starting balance. So let's say you put in negative 100. So that'll come back up and it'll say error, negative starting balance, negative 100 is what will show them if we do that. All right? And then they test it by actually giving it a negative 100 balance, and there it is. Does all that make sense? I don't know about you, but I think especially after some of the stuff we've had with classes and polymorphism, this is about as straightforward in advanced Java as it gets. As far as using that exception tag in there that they talk about, all right, and if you're going to use Java doc, okay, you put it in like this. And again, if you run the program with Java doc comments, that'll put that in there as some documentation. I'm not requiring that you do Java doc. All right, I know people who are Java programmers. I don't know any of them that use Java doc. All right, but I think it's a nice thing to have. All right, I don't see why people wouldn't use it. It's not a lot more work, but not everybody agrees with it. All right, jumping up to page 756. 729, sorry, 729. So jumping up to that page, now we're getting into the advanced topics. All right. I want to keep this short and sweet. 155, we're done with this topic. But you all know this right now, that if I come through here and do something like this, all right, I'm going to go to my H drive. This is going to look really terrible, but you'll understand hopefully why I'm doing it in just a second. There's our book, right? If I double click on it, it's going to open it, and it's going to open it up. It's already open, but it would open it up in Adobe. All right? But now I'm going to right mouse click on it, and I'm going to choose open it up in Notepad. And what does it look like? Not very good, correct? Because I'm attempting to open a binary file. And I'm attempting to open a binary file by using an editor that's set up for text files. And the reason I'm telling you that is when the author talks about a binary file, text files are any file you could open up with an editor like Notepad. That's a text file. And almost always it'll have a .txt extension on it. All right? Binary files are basically everything else. All right? And that's what he talks about in here. Okay? So what he says is if you want to work with binary files, you do a lot of the same stuff you do with regular files. You use file, output stream, data output stream, etc. But he actually has in here a program that's really simplistic. It may not look like it. But what he does is he takes and he creates an array with these values right here. All right? And so he takes a program with those values, and notice, here's the thing. 246810, no biggie. Notice what he writes it to. He doesn't write it to numbers.txt, he writes it to numbers.dat. As soon as it sees that it's a non-text for the extension, it says, oh, it's a binary file. So if you try to open it up, if you double click on it after you create it, even though all it has in it is 246810, you're going to get an error message. Did you ever try to double click on a file and it comes up and it doesn't know what to use and it gives you a little magnifying glass and it says pick, that's what it's going to do. That kind of thing, because it doesn't know. Not only that, since we're working with a file in here, all right, if you look, this is the whole program. Everybody see it? That's the whole program. Somebody tell me, where's the TryCatch in there? See, well, there isn't one. Is that a trick? No. If you don't put the TryCatch in, then you've got to have something like this that lets the system know, hey, it's possible Java throws, with an S, an I/O exception with this. So we're not handling it in here. We're telling it that Java could potentially. You'd say, well, what does that mean? It's going to break, right? All right. If when you put something like that in, you're fairly confident that it's never going to happen. Because you're not really doing any exception handling. You're letting the system know that Java will handle it. We already know how Java handles exceptions, right? It stops your program. All right. And you run this one, it's happy as hell to create the file and write it out to numbers.dat, and it says done. So when you open that file then, and you try to read it, all right, it's a binary file because it's a .dat. You've got to handle it as though it's a .dat. So you've got to use the different types of streams that they show in here. Again, you're not going to have a program in that. I'll just let you take a look at it, and maybe not right now, but if you have a question or something, I can try to help you with it. Now, notice in here, throws I/O exception. Notice it says here, main, throws I/O exception. And we've got an I/O exception here. Again, the good news about this is if you run the program and the program wants a throws statement and you don't put it in, your program's going to give you an error message that's going to tell you that. With some of it, it's a matter of looking at enough code. Do I need that here? Well, it never hurts to put in that it could possibly throw it. All that's doing, that line 11 that's partially in blue that you see up on your screen right now, is that's telling the system it is not impossible that this particular program is going to throw that kind of exception. Not that it's going to happen, but it's possible that it could happen. All right? So you might say, okay, fine. What if instead of numbers.dat right there, I put in numbers.dit? DIT. That would be an error, right? So what it would do, it would throw a file not found exception, or I guess not an EOF, but it would throw some kind of an exception. All right? Normally when you see code like this, the try should always work. That's too much of a blanket statement, but it pretty much is the truth. All right. You probably have heard me say this to you in other classes, but I'm going to say it again real quick. I'm dating myself here. There's a few people in this room that are younger than I am, but close to my age. Remember the days before DVDs and CDs? All right, for a while at least, there were 8-tracks and there were cassette tapes. All right, and again, with a cassette tape, you're at the beginning of the tape, you want to hear the last song. What did you have to do? Listen to all of them or fast forward, right? Now today you can punch in the number you want because that's how it works. But in the olden days, when you had to sit there and listen to it or fast forward or whatever, that was sequential access. You had to go one after the other. Now we've got random access where you can jump right to the one you want. The biggest thing about random access is it allows you to do what's called update in place. So if I've got an error in record 500, all right, there's 1,000 records and I've got an error in record 500. With a sequential access file program, I've got to read the first 499 records into a new file. Then fix record 500, write that, and then write the other 500 records. When I do an update in place with random access, I jump right to the record I want, I change it, and I go on my way. So, well, that sounds like it's a lot nicer, but there's more work involved in it. And many applications are fine being done sequentially. There's not a problem at all. But when you start to work with random access, and again, they're showing how you can jump right there. First of all, when you work with random access, imagine I had in here, for every one of you, first name, last name, address, city, state, zip, all that information. All right. Then each one of those. So imagine we had somebody in here with a really long last name. And then we had somebody with a really short last name. When you work with random access files, every field in every record has to be exactly the same size. Because when the computer figures out how to get from record 1 to record 500, it needs to know how many bytes to go forward. So everything has to be, for every record has to be exactly the same size. The content can be totally different, but the size has to be the same. All right? And that's why you can jump right to it. So they show you some stuff in here with random access. I'm not going to talk about it. All right? The last thing they talk about in here And again, I'm going to jump back to my friend here. Wikipedia, because I always say this in reverse. I don't know why. I'm going to type in serialization. All right, this article is about data structure and coding. All right, that's fine. Okay. Maybe what they have in the book is better. Let's take a look. All right. Everybody see this in blue? When an object is serialized, it's converted into a series of bytes that contain the object's data. Oh, that makes perfect sense. If you were in the networking program, all right, if you were in there and you were talking about sending data, they would talk about sending data in packets. And the problem is fine, except that these packets that you're sending data in are of a certain size. So let's assume that the size for every packet that you could send at a time is 10,000 bytes, okay? I'm just making that number up. But let's assume that the data that you want to send has got 100,000 bytes. Does that all make sense? So you're trying to stuff 100 pounds into a 10-pound bag. So what you do is you break it up into 10,000-pound chunks. Does that make sense? That's serializing. All right. Then when on the other end, when you have to take all those 10 different 10,000 chunks and you have to put them back together again, that's deserializing. All right. So the example that I've given in the past, and you may have even heard me say this, is imagine that I have a house. I always use this example. I don't know if you remember the show, but back in the old days when what was the show with Tim Allen, the Tool Time show, Home Improvement. All right. In the last episode, his wife got a job in Indiana, and he quit his job so he could be with her. And she kept saying how much she loved the house and how he'd built it and everything. So what he ended up doing was they took the house off its foundation, put it on a trailer, and he was taking it over there. Well, that's not probably what would really happen. But imagine instead of doing that, they were literally, let's say it was a brick house, and they were going to take it apart brick by brick and then put it back together again in the new location. You with me? The act of taking it apart brick by brick, that's serialization. The act of putting it all back together again when you get to the new location, that's deserialization. What's that? Yeah. But in order to do that, again, the problem is what they're talking about doing here is, let's assume that what I want to send through the wire is Java. But it's a class and it's got all sorts of information about people. It's going to be so big I can't shove it all through at one time. So I serialize it into chunks, shove the chunks through, and then on the other end I got to deserialize it or put it back together again. That's exactly what they're talking about here. All right, we've reached the end of the chapter. So what we're going to do is we're going to break, and after the break I want to make sure that everybody understands this. So I'm going to go back. I don't need that, but I'm going to go back here. Yeah, you do the serialization and the deserialization in the code. Yes. There are methods to serialize and to deserialize. It depends on what it is you're trying to do and how you're trying to do it. Imagine that you're moving something from one machine to another machine. All right? In other words, let's say that you were using Java to write your own file upload type of program. All right? And let's say that it was only possible over the wire at a certain amount of time that you could only pass so much data. So you'd be chunking it and unchunking it type of thing. Yes. No, it's not that it's not used a lot, but there aren't like a whole boatload of really good examples to give you with stuff like that. All right, so after the break, what we're going to do under the homework, under the comments for Chapter 11, is we're going to look at this, and I want to make sure, I showed you this the other day, everybody understands what it is you're supposed to be doing. So let's come back, let's make it 10 after 2, and I'll probably just go for about 10 minutes or so, hopefully.